Oh, hello, welcome to the show. It's me, JP. Thanks for coming to John Park's workshop. Here we are. There is all kinds of fun stuff going on today. Particularly, I'm almost out of breath because I've been setting up to do a demo with the espresso machine and the tank, the water tank depth sensor. So I got that all set up, moved over into here. So I'm excited to show you that, and I had to do some camera rearranging, and there may be some mid-show rearranging as well to show you the stuff. But I'm thrilled at the progress on this gizmo and how I think it's going to benefit mankind, or at least my espresso intake, but maybe yours too. I'll be writing up a learn guide on how to build your own water tank meter with IoT action and battery-powered deep sleep if you need to be remote. So that is what's going on with the project. Hello to, checking out our chats over here. We've got people over in our YouTube chat. Hello to Dave Odessa and Johnny Bergdahl. Thanks for popping in over there. And then, if I can find it, here is our Discord chat. Hello to John Nodge and Squid.jpg, Johnny Bergdahl. Hey, Lars. Thin Man. Howdy. C. Grover, Andy Calloway, Paul Cutler. Hello, 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 hello. Does Lars drink coffee, asks Andy. Yes, too much coffee. He started out just a normal sloth, and then he drank way too much coffee, and now, well, I think you know the rest. Let's see, what else? Is there such a thing as too much coffee? I don't know, probably. He might become hyperactive, yes. What else? What are we doing? I've got a coupon code for you so that you can save some money in the Adafruit shop. We've got a new recap of my product pick of the week from this past Tuesday. I'm showing the little gizmos back here, actually, that I was demoing. I've got a CircuitPython Parsec, kind of a fun one for you today. And then we'll dig into a little bit of the water tank meter 3D printed lid mount, which I'll show you how I built that and what it looks like in the current version of it. I might still make some revisions to it, but allows us to use the typical ultrasonic sensor, little sonar sensor, in a overhead orientation. So it's just looking down at the water below. I'll show you that in Rhino and Grasshopper, where I made it, and the little 3D printed part that I have. I will also do a demo. Did I mention? I think I mentioned in the blog post. I'm going to do, I think, a live demo of pulling an espresso shot on here and maybe doing a little, do I have a, yeah, I have a little cappuccino, a couple of cappuccino cups, so a little cappuccino latte art on there. I'm no expert. There are better places on YouTube to look for people doing latte art, but I'll put myself out there and show you what I do. Is that going to be it? I think that'll be it. So let's do it. Let's buckle up. First of all, discount code Machina. That is your discount code for the day. If you want to save 10% off in the Adafruit shop, just head on over to adafruit.com, throw stuff in your cart, just heave it in there as much as you can in as short a period of time as possible, fill it up, and then on the way out, type in the coupon code in the coupon code slot, which is Machina, which I'm kind of, see, I can make it a little more legible if I go like this. Machina, which is Italian for machine, also car, but in this case, machine. M-A-C-C-H-I-N-A, Machina. That will get you 10% off in the store today. And if you head on over to the store, where'd mine go? Here's the Chrome. Here's the Chrome. There it is. We've got a little happy, I love that Year of the Snake Blinka there for the Happy Lunar New Year. And Happy Lunar New Year to people who are celebrating. On the Adafruit page, main page right here, adafruit.com, you'll see we've got new products listed, some neat new stuff you can go check out. This will even work on these things. These, if you need a 100 by 20 inch, I'm going to guess inch, or is it 100 by 20 LEDs? 1 by 5 meter. Yeah, those are not inches, those are LEDs. 100 LEDs wide, 20 LEDs high. It's a $449.95 NeoPixel net. Pretty sure there's nothing to stop you from getting 10% off on that. Whoa! And we've also got the one below it there, 80 by 20. These are pretty cool. I know Aaron St. Blaine is going to be doing some cool stuff with these using some not WLED, but I think the other one, XLED, is that what it's called? Driving a ton of LEDs to do these cool displays. You could go maybe pick up some related stuff. There's let's see, what else have we got? The Sparkle Motions are out of stock, sorry to say. But if you check through here, this is the new. There's also under products the featured. You can go check out some of this stuff, and then of course you can just go through these categories and look for some things. Are you prototyping? Maybe click on prototyping and pick up some breadboards for 10% off. So that's how you do it. Throw it in your cart. On the way out, type in Machina, and that will get you 10% off. So next up, Tuesdays are my product pick show. I had these cool little Nixie tube looking displays this week. These gizmos. Here's a little recap. Check it out. That is the product pick of the week this week. It is the Nukie. It is a TFT board. It's 1.14 inches. It is 240 by 135 pixels. It's an IPS display, and it is designed to be used vertically. So plug in, just like a Nixie tube, 3 displays running on a single microcontroller, all sharing the same everything. So these are not separately addressable the way I have them set up right here, right now. But I do have them doing just a slightly randomized slideshow between displaying some lit up numbers versus some just going blank. Here's a little clock I built for it. So I have a Feather RP2350 and a little real-time clock Feather wing. And I just plugged these into Feather Tripler there, and I have a nice display there that alternates between the day, date, and time. The Nukie TFT display. Yep, that's it. Question from the chat from Some Nice about these, if I can find it, there we go. These are the nets that I talked about, these 100 by 20 NeoPixel LED nets. They are somewhat ruggedized for outdoor use, which is nice. So they've got some tabs for connecting them onto screws or other fasteners, as you can see there. They have the data ground 12 volt was the question. These run on 12 volt, yes. Some nice mention wanting to wrap a car in it. I've seen this. I think it's illegal and a bad idea on the roads. I did see it over the holidays. So a lot of people were wrapping their cars. Not a lot, but enough that I saw them a few times around, driving around. But if you're somewhere safer in the privacy of your own Burning Man camp or something, but sure, these would be cool on a car, I suppose. You can see this here using those hang tabs there to connect it up to a rod with some string, and they are laid out for you. As Lamore mentioned, these are expensive compared to just buying a bunch of strips of LEDs, and largely that's because they are laid out in this grid. They have a rugged wire running horizontally to hold the thing's shape, to keep it from falling apart. So for sure you could do this with regular strips, but I think if you're doing outdoor kind of stuff, if you want to leave it out a lot or wrap your car in it, you may want something a little more rugged like this versus straight strips. This can draw as much as 60 amps if you put all of them on full brightness. So you need a big supply. For typical use where you're not running every pixel all the time on full white, we usually calculate a third of that, so 20 amps. It's 12 volt, 20 amp supply. It's pretty beefy. All right, so that's some fun LED netting talk. Next up, let's do a CircuitPython Parsec. CircuitPython Parsec. There we go. Sorry, I was talking over the intro there because I was opening the wrong things and talking to myself. Nope, that's not it. That's it. I switched IDEs. Did I mention this? This was Paul Cutler on the Bootloader, I think, on the Bootloader podcast with Todd Kurt, was talking a few episodes ago about some favorite things, and one of them was Zed, this editor from, I believe, some of the developers who did Atom, which I used to like, but it kind of got sunsetted. And so I've started to make the switch over to Zed, and just now I accidentally launched a different one, Sublime Text, because I'm used to that. But on to the actual content. For today's CircuitPython Parsec, I'd like to show you how you can use a bicolor matrix LED with shifting of pixels. That's a weird way to say that. I want to show you today on the CircuitPython Parsec how to shift pixels on a bicolor LED matrix. So these are the HT16K33 backpack type of matrices. We use that chip in a lot of products. You have a lot of 7-segment displays, and I believe some of the 14-segment displays use these, and other various shapes of LED matrices. This is the type that can do, as you can see, 2 colors. You got red and green per pixel. You can also mix, so you can do a sort of orange, yellow-orange in between. One of the neat things about the library and the driver for these matrices is you can do some pretty neat animation with very low code overhead. So you don't need to figure out things like blanking pixels and redrawing them as you move a pixel around. You can use this really clever shift function. So here you can see I'm importing the HT16K33 matrix, and then this matrix 8x8x2, and that refers to the width, the height, and the number of diodes, number of colors per pixel. And I'm setting that up on a little QT Py. You can see there over I2C using stemma I2C. Instantiate the board as matrix. I'm setting the brightness here. I've got it fairly low just because that helps with putting it on camera. In fact, let me lower it a little more and see how that turns out. Yeah, that's worse. Let's go up a bit. Let's try. Nope, it was good at 2.5. All right, 0.25, and ignore my comment here, or let's update that. Next thing I'm doing is just filling all the pixels with off or black. So matrix.fill0 will set them all off. And then I'm waiting a moment. And then ignore this stuff. This is just some playing around I was doing. But the key thing here is that I am drawing a little box here. And this just loops around and does the 4x4 green. And then it does it again in the center 4 as red. right here. And then right now I've set up a variable for speed. How quickly do I want to shift the pixels around? And am I going to wrap them? So let's get to the meat of it. Instead of telling the main loop to pass, I'm going to now tell it to shift the pixels, any pixels that are on screen, so matrix.shift, and then an X and a Y direction. This happens to be sort of backwards. The 0, 0 origin is in the upper right corner, so to move left, I'm going positive, and to move right, I'm going negative. But this is going to first shift all the pixels to the left, and then you can see I'm taking a little pause there for 1/10 of a second. Then I'm going to shift them back to the right. Then I'm going to shift them right and up, and then I'm going to go right and down, and it's going to repeat that. So if I resave this, what you'll see is the pixels moving around on the screen with this very simple command. It doesn't require me to address every single one of them. It's just whatever I've drawn on there, I can then go and shift it around. And you can see with the wrap on, it will wrap around to the other side when it appears rather than disappearing. We can adjust that. If we set this to false and hit save, now you'll see when it gets to the edge, it just cuts off and it doesn't loop those back around. And so this thing is just driving away. We're never going to see it again because it's essentially moving down and right, down and right, down and right. The only reason we were seeing it come back before was because of the wrapping, where it comes back around the edges of the screen, essentially. That's how we see it coming back, sort of kind of a tile of itself. And so that right there is how you can use pixel shifting on an LED matrix inside of CircuitPython. And that is your CircuitPython Parsec. All right. Yeah, good. I left my mic on again there. You probably heard an echo. At least I wasn't yelling at my computer. All right, so next up, let's dive into a little bit the design of this water tank bracket for the ultrasonic sensor. So in fact, I'm just going to grab it off the machine. I'll show you in a bit how that fits onto there. But this is, it's going to skew my data. So when we look in a little bit, you'll see my data's all over the place just because I've been moving this thing and plugging different batteries in and so forth. But this right here sets on top of my water tank, and it aims the little ultrasonic emitter and receiver pair on that little ultrasonic sonar distance board. It just aims it straight down at the water, and it reflects that back up, counts the amount of time that little bat signal echolocation takes to come back, and then sends me an answer over the featherboard here up to Adafruit I/O, and then I can measure the tank fullness. And I'll actually pull the tank itself out. It's got a little removable water tank. So you can see there, you can see the water sloshing around there. That's what we have. It's like a HDPE, high density polyethylene type of milk carton type of plastic, I think. And it has a little valve there, so when the machine requires more water to go into either the water tank or the steam tank, it will draw it from there. This will head down. You can see moving around here, there is a little magnet sensor. So there's a magnet in a piece of foam there that lowers, and then there's a Hall effect sensor inside the machine. So it knows when to stop trying to ask for water, so it can turn itself off and not burn out the heating coils. And so that's good for the machine, but it's bad for me because that means, oh, let me bring this back out so I can show you the connection here. But that's bad for me because then I don't know that I needed to fill it unless I open that lid and check. There's not a convenient way. It's essentially just a flaw in the design of the machine. So it's not a good way to tell how full the water is. So this bracket here, if we set that right there. It just fits into place pretty snugly, and without me dumping water all over my keyboard, you can see the little view that that sensor has pinging down there and off. So I'll keep this here. I'm going to set that away. And then we can just talk a little bit about the design there and putting that together. So close the machine up. And let's hop over to Rhino and Grasshopper here. So that should be a good, yeah, that should give you a good view of the world there. So there it is. There's the bracket as I modeled it, and then you can see I flipped it upside down and turned it into a mesh for export. So that's what these, a little bit easier to see. Those are essentially two versions of the same thing. So it's a fairly simple build here, and it did it parametrically so that you could potentially adjust this for a different tank, or if you want it to be just a little tighter to the walls, or it's too tight, you want to bring it in. We're not going in and editing the model. We're not going in and hand editing curves. It is all done parametrically with these little nodes over here in Grasshopper. So let's take a look. I'll go back to the shaded view here at the pieces and parts. So the way I have it set up right now, this green model, that's the parametric model. As I click on nodes over in Grasshopper, you'll see parts show up or disappear. So it's essentially two clusters of stuff that I put together to build it. And I forgot to add these little guys to this group, so let me move them into there so they don't get lost. So if I go to a mostly top-down view here, you'll see we start out with this rectangle, and I'm using a little parametric rectangle creation node that's just asking for a plane. I'm letting it use the default XY plane of the world, a X dimension in millimeters. So I essentially grabbed calipers and measured my top of the tank there. It was 174 by 80, so that's just the starting curve I'm making. And it also lets you input a radius for the filleted corners, the rounded corners. So it's a 3 millimeter radius. Felt good. I measured it as best as I can without a dedicated tool. It felt like 3 would work. And then this curve gets turned into a couple of other curves. So I'm using offset nodes to take those 3 curves and do a little bit of an offset in negative space, so 3 millimeters in, and a larger offset out, so 5 millimeters out. So that's what this little collection here turns into, is 3 curves that can be the outer lip that sits on top, and then the inner, which will run down on the insides a bit. And I can make that longer if I want to get a tighter fit or a stronger fit. In this case, it's not super necessary. But all those are just based on some of these next sliders here, where I go through and take what are just curves. And granted, I'm drawing them nice and thick here so that they're legible. But those are just 2-dimensional curves in this case, not surfaces. I then go and individually extrude and cap them into sort of solid surfaces. So this curve gets extruded upward, no, downward, sorry, checking my nodes there, 3 millimeters down. This one is 6 millimeters down. I can put little caps on those, and then I made another one to cut out from the center. So those 3, if I then start to combine them with Booleans, I can add them together and subtract them from each other. So we have these 2 pieces, and since they're all sharing the same curves, they're perfectly coincident, which means it's easy to seamlessly Boolean union them together into a single piece. So that right there you can see is what gives us the, and let me make a preview node so this will render so you can see it a little nicer. So the pink one here is the render of what we have so far. So that gives us the outer part and the little lip that hangs down. So if I wanted that lip to be a little deeper into there, I would just increase, I think it's the, is it you? Yeah, so we'd increase that. It'll cause the render to look funny. Increase that slider there. I made it stop at 10, but we could increase that if we wanted to. And that's what is giving me that little lip that goes on the inside. Then let's take a look at the other section of that, which is the bracket piece for mounting the actual ultrasonic sensor. So this, you can see, these are fairly standard size even among different models. So I measured that, what did I get, 80 by 20, is that right? 40 by 20 or 18. So that's the dimension of the PCB. I think I just scooched it up a little bit. That gave me just a starting point. I actually use that one directly. I scale it up to be bigger. You can see that we have a little ledge there that we can set it onto, and then measured the diameter of the little ultrasonic sensor emitter and receiver parts, as well as their spacing. So calipers are your friend there, unless you can find some good dimensional drawings in the data sheet. Then you might still want to measure it, because those aren't always exact matches to each other. So in this case, we start off with this. Actually, I can leave this in this nice rendered view, I think. So I start off again with a rectangle where I've just fed it some dimensions. Then I move it where I need it. So it wants to build it initially at the sort of origin of the world, 0, 0. So then I just created a little vector to move it in X and Y. And I use some little sliders there just to put it where I want it. We can look at, if I show some of these ones. So those are the initial curves and where I've moved this to originally from there. I end up moving it here. And then I do a bunch of little nodes that grab things like the area of it to find its centroid and the edges of it to deconstruct it into edges. Then I can say, okay, on edge 1, give me a midpoint. And then from there, I've got the midpoint of the object so that I can position the circle cutouts. So that's a whole bunch of little nodes there. And you can take stuff like these in, I'm using Rhino here, but a lot of people will use Fusion 360 or SolidWorks. You can take things like this that you commonly use and wrap them up into little sort of macro groupings of collections of nodes, so you can throw those in without reinventing the wheel every time. Sort of a more advanced copy and paste. But once we have done that, we can create circles and place them where we want. So here's my 2 circles, and here's my initial rectangle. So that's pretty much the dimensions of that and placement of that green board and its circles. So that's perfect for then making, again, a little resting ledge for the PCB to set on and to cut out or Boolean difference out a couple of cylinders based on those 2 circles there. So you can see we've got a couple circles which are ready to do some cutting. And we've got, as you can see there, that first rectangle has now been expanded. So let's find, there's my initial rectangle. Then I've got an offset to it, giving it some rounded corners, extruding it, putting a cap on it, and then cutting out those cylinders from it. And then the last thing is to combine all those, and that's how we get this. And then lastly, this is basically upside down as far as 3D printing goes. It's much easier to print the bigger stuff and not have overhangs. So this is a nice object for 3D printing. So I export it or sort of bake it as geometry that's usable in the interface. You can see I can't touch any of this stuff because it's only made by magical nodes. But once I've got the real object baked in here, I flipped it by hand. It's easy. I could do it as a node as well, but I decided I'll just do it by hand there. I think I went in and hand chamfered a little lip into there to make it slot in nicer. Again, that was just faster to export and do, and I don't have any further steps. If I did have further steps after that, then I would want to, again, deconstruct the object into edge numbers, find the ones that I want, and run a node that puts that chamfer on there. And then I export it as, or convert it into a mesh, and this is just me saying, hey, I want to have control over how many polygon triangles there are going to be to keep edges smooth. So your STL that gets opened up in the 3D printer, software for slicing, in this case I'm using Bamboo Studio, may or may not do a good job of taking a step or other NURBS geometry or a solid and turning it into the mesh. So I like using the tools here just to say this is the exact mesh, and then I'll export the STL without changing it. It's already a triangulated polygon mesh, and you can see here I've got a lot of geometry where I need it. There's places I could probably make it more efficient, turn those into planes, but that's okay. It doesn't hurt anything. But this is going to be a nice resolution for 3D printing, and that's how I got this guy right here. So you can see, I'll go to a full view down cam, move that off to the side there, and I'll refocus, and let me up that exposure a bit. There we go. So there's the model. It's just resting in there. My next step is going to be to create a little backing case, essentially, that'll probably screw down into here and just cover all of this in the connector, just to make it a little bit splash resistant, because it's an area that's got some water and moisture. So it probably would benefit from just gluing something down, cover all of this with a 3D printed part, and use some glue to connect it so that it's pretty darn sealed up, or use silicon caulking or something else to sort of pot the thing. Of course, this is open, so we could splash up into here. Hopefully we won't. Interestingly, the tank is not closed. We talked about this last time. The tank is kind of an open design. There's a metal cover that goes over it, but it's not sealed up, and I think this is to prevent mildew from growing in there. You don't want the environment that the tank is to be a moist environment. So there's some water loss from evaporation, especially in a climate like Southern California for sure, but that's okay. So there we have it. That now what I'll do is let's take a look at let's go to Chrome. And here is the Adafruit IO dashboard. So right now you can see I have it every 5 minutes, just because, again, I'm in the middle of testing things, so eventually this can be 15 minutes, an hour, or something like that. But right now, every 5 minutes, so you can see when I started talking, I grabbed it out of the tank, and then you can see the numbers have started to change here. So, oh, did this turn off, or did I turn it off? Did I wiggle something off? There we go. Let me turn it back on. Yeah, let's see. This will probably report if I just hold it right here. Oh, I didn't know I was still there. Let's see. Can I look at just those? Yeah. So, oh, you know what? It's also it may be having a hard time finding my Wi-Fi because I'm not using the one that's in the workshop. I'm using the one back in my studio office, and now I've moved it somewhere that it. Yeah, I found it. Okay. So yeah, 3 centimeters is what it's reporting right there. Battery is high, it's up at 88%. So now I'll move this into here and we should see the numbers go back to, I think, what those graphs indicate. So I'm going to set this here. I've used one of our silicon ribbon cables so that I don't have to drill in or take anything apart from the machine. I can just fit that around the lid. You also maybe saw I have magnetic feet on there, so I may put a 3D printed case around the feather and the terminal block feather wing and battery, and magnet that to the case. That might work, or put it in a small like Pelican case with a little cable gland for moisture resistance. So yeah, in 5 minutes we should see a number, I think. Yeah, should be like what you're seeing there, around 15.2 centimeters. You can see I updated the dashboard here to have a completely useless but cute coffee cup icon, a little espresso cup icon. That can be used for stuff. I think it can act like as a status indicator. I'm not using it for anything. I just found it in the Adafruit I/O dashboard and threw it on there. I do have the battery indicator, so you can see that's saying it's at 74%. And now on Tyeth's suggestion, I put 2 graphs. I have a live graph, which is the last couple of hours. And then I have a 7-day graph on here. So ignore spikes. That usually means I moved it or was testing something. But this is sort of the life of this over the last, oh yeah, I reset things. So this is, I think, just the last day right here. But this, if I turn that on and leave that on, we should be accumulating a 7-day on here. I think the feed will show that too if you just go to the Adafruit I/O feed. And then the same thing, I have a little battery for the a little graph for the battery. So there it was, let's see, on the decline 30%, 31, 30, 29. Then I started charging it, and you can see it charged pretty quickly. So now we're up at 74% here. This was, let's see, from 11:41 a.m. today to now, which is about 1:30. We had, this is the battery getting charged from about 40% up to about 70%. So it's pretty quick. And this is again a longer, if I leave the thing on, we'd get a 7-day graph there. I think that's what I set that to. Actually, no, I probably set this one for a month. So if you go into Adafruit I/O, edit layout, each of the widgets has a little gear on it. And yeah, I set this one to 60-day because I think based on the power estimates that I was doing last week, I should be able to get a month and a half out of that battery. A lot depends on how frequently I'm checking it. I do have it stopping at 3:30 p.m. At least that's in one version of the code. I may have opened that up again because I was testing it in the evening and wondering why the thing wasn't turning on. But ultimately, having like a 60-day battery graph on there will probably be useful. Go cancel this layout change. And okay, yeah, so there we are at about 88%. That doesn't seem right. Something's wrong with that. That is not the percentage. Or has it not checked again since I... Yeah. Yeah, it has not checked again, has it? Are you on over there? Is something loose? I don't know if I have a loose connection. I'm going to plug it into power. I know it's cheating, but I just want to make sure that we can demo. This thing, and hopefully it is finding the Wi-Fi. Let's see. That's better. Yeah. Okay. So that's the numbers we were looking at. We're expecting so 13.9, and that may just have to do with me moving things around. So that's the water level. Let's now take a left turn into making an actual cappuccino over there. And I may need to just dump out water. I don't know if just one drink is going to be enough that the tank wants to pull water from the reservoir. But if it does, we should hear it. There's a pump sound that you'll often hear of it refilling, and we should see the values change. So I'm gonna switch up some cameras. Let's go to that view of the world. That's probably good, and I can change it from over there. And yeah, you know what? Actually, I want to make these two about the same size so that you can see both and I don't have to switch back and forth between cameras. 1 second while I do this. All right, that should serve us for the view. And this is the process. Oh, so this, by the way, is a Pelican case I was thinking of using, but there's usually not a great way other than hacking something and trying to reseal it to put a gland on there. We have some little cases that have a cable gland option. I may use one of those. Okay, so this is on. First thing I want to mention, this is, I had said I'm using these minerals, so I'm taking demineralized water and mineralizing it. So I buy the distilled stuff, and then I add water back into it. So at some point here, I may refill it, and we'll also check and see what happens. So this is, I'm explaining this to say this is why I don't have the machine plumbed into the wall. I used to have my old machine plumbed in to the wall through a filtration system. Worked okay, but this is way more predictable as far as knowing what minerals are going into the water, into the machine, and into your coffee. So we will start off with weighing out some grounds. And I'm going to do 20 grams of beans. These are, I think, a Portland company, Nossa Familia, and this is one of their espresso roasts, or an Italian roast that is medium dark roast, which is darker than I usually do. I usually like a medium roast, but these are not at all over roasty or burny, so that's good. So let's get about, whoop, I'll lose some here, about 20 grams. Looks good. Goes into the grinder. Grind that up. There's some grounds that like to get trapped in the chute there that I like to puff out. Try to get them all into the portafilter. Hopefully you can see most of that. This is actually a little 3D printed tool that has some slightly blunted acupuncture needles in it that's really good for breaking up clumps, essentially. So I don't want clumps in there. And there's a whole bunch of fussy stuff you can do. I try to be fairly minimal on the fussiness. But the point a lot of this is that you're trying to make a puck of coffee that's consistent in density, so that there's no easier path for the water to travel, which means it'll run your shot fast and not extract as much coffee. So you want a fairly even distribution of coffee and evenly tamped, and that's what that little tool is helpful for. So there's the puck of grounds in there, and now the machine. I don't know if I can, let me see, is there easy, I don't want to mess with the camera yet, so I'll leave that where it is. And let's make a little cappuccino in there. You can kind of see it. So watch the level on there on the Adafruit I/O. I'm going to pop that up on the screen, actually. I should have probably set this to be like 30-second intervals, but we'll just go with historical on that. So what is it saying we're at? I can't see it that well. Whatever it's at, I can see the graph. And, oh, let me tear the cup. I'm going for about 30 out, so I put in 20 grams. I want about 30 grams of espresso, so the water extraction coming through. That's a nice starting point recipe, and you can go different directions from there. I want that to take about 30 to 50 seconds. So this is looking like 20. So this is about 30.9 grams, 31.2 grams in 33 seconds. That's great. That's a good, and to be able to get that kind of consistency, a lot of it comes down to tuning up the grind and the tamping so that you can always get roughly that. And it'll change over the course of, if you've had different beans, if you've had the beans for a little while, those things will change. So I didn't hear the pump kick on, so it should still be the same level in there. The reservoirs, the two boilers inside the machine, haven't grabbed any yet. That may change now when first of all, I'll try a little sip of this. Delicious. I am gonna steam some milk, and that will probably pull enough water from the steam tank that this will kick on and ask for water from the reservoir. So this is just some milk that has hopefully stayed fairly cold. And I'm just gonna get some of the water out of the wand here. And so I'm just trying to introduce some air at the very beginning and then swirl that air for the rest. So it should be fairly quiet. You don't want to be bubbling a ton of air bubbles into there. And you want that at about 120-ish degrees, which you don't need a thermometer for. You can usually, after a while, have a feel for that. Okay, I just heard that pump kick on. You might have heard that ding-ding after I turned off the steam wand. So that means we should see a change in the next reading that we get. All right, and now for my hopefully not too sloppy pour. There we go. We got a little heart sort of thing. There we go. And now I get to enjoy that. And yes, my relatives in Italy would be aghast at having cappuccino this late in the day. It's a breakfast thing usually, but I don't care. I love it. I also usually don't drink it during the day, but. Okay, so now we can take a look at this view of the tank here. Let me just. So that's the tank opening there, and you can see the little IR or sonar ultrasonic right there. Andy Calloway just posted a very nice Lars drinking some coffee Photoshop. I'll show that in a second. So there it is. That's what's looking down in there. I'm gonna see if I can tip this camera. It's on a big tripod, but I'll try to tip. Whoa, back here. And I don't know if I can get a light bright enough in there. Do I have a handheld one? I don't have an easy handheld one. Let's see. No, we're never going to see down there. But luckily, we don't have to. And you can see that's such a pain normally. I'll leave that camera alone. Because I have all my cups on top of there, and I got to reach over all that. So usually I have like, 12 of them up here for various family members wanting coffee through the day. So that's the flaw. That's what this whole project is about. I don't want to deal with this. I just want to look at the AIO dashboard there. have it send alerts. I've got it's a snap set up so that it's sending me info. In fact, right in the morning when I wake up, when my wake up alarm goes off, it through Apple shortcuts does it's a snap to request that number and just send it to me, so I know when I walk down to the machine, one of the first things I have to do is fill it or not. So let's see, what did we get? Okay, excellent. So there's the, let me switch some cameras around there. There is the proof is in the pudding, right? So we had 15.2 centimeters in there. Now ignore the 3.4. I'm looking over here. Ignore that 3.4. That was when I was just moving it around. But this is after I made the cappuccino. It, due to me running the steam wand, requested water. It got the water. In fact, what I'll do right now is pour out into a cup. I'm just going to pour out some of the, there's a tap for the steam wand. I can get some water out of there that might force it to drop lower. Let's try that. So it just turned off. So my machine, the little light on it just went off because it saw the little float magnet in there go below the certain level. So it just went into rest mode. So our next Adafruit I/O feed, when that kicks in about 2 minutes or so, should be somewhere red. Should basically say that we're at close to 0. I haven't actually checked what number that is, so that's actually kind of important. I'll do some more extensive testing on my particular machine to know, because it's not the bottom of the tank. It's actually a little higher up than that, where the water level drops that little magnet sensor. As promised, while we wait for that, let me show. Move this over here. There's Andy's, Laura's enjoying a big cup of coffee. Oh, my gosh, coffee, so good. All right, so let's bring this view back here, hide that. Some other, future developments I could probably look into. If anyone knows about this, I'm curious, are there wake commands that can be sent wireless during deep sleep? It would be interesting if I could have a button on the dashboard that just pings, wakes up the machine, makes it. I have no idea if that's possible. That may be contrary to the notion of it's deep sleeping. So I know wake on network stuff happens in the real world on wired networks, but it seems like it would have to be waking up on some level to check for anything, like doing a connection. So could also have a button, a physical button, connected up to the terminal block feather wing, so that I can just do a immediate wake up right there. Let's see. We should be about half a minute away from it doing. I want to see if that works. I don't want to have to go over and undermine the whole thing by touching it. This should all be hands off. Look at this. I don't mean to torture you, but look how lovely coffee is. Lovely. Dave Odessa requested a double espresso. Tyth Gundry, yeah, you would have to have a feed to toggle if deep sleep mode was on or not. Then when it posts the distance to IoT, it gets the mode feed and adjusts. I see. So you'd wait, you could send a message that would wait for the next wake up. Is that it? Maybe I don't see. All right, feed. Oh, it's wrong. That's interesting. That can't be right. It says 13.8, but I'm gonna look and see. That's definitely not true. Okay, I'm gonna force it to send it. And then if we have time, I may actually update the code to do like a every 30-second sync, just so we can see a more live. Yeah, but that's wrong. There's no way that that's 13.8. Now it's saying 15.1. All right, last week's demos were much better as far as this part of it. I don't know what's happening. Let me point it at the ceiling and force one. What could that be? Let's see. This should go red. I'm pointing it at basically at nothing. Yeah. All right, let me put it back in there and see why would it lie. Oh, I put it in wrong. I put it in pointed at a piece of plastic. I flipped the whole thing 180. My bad, sorry. Yeah, my tank is symmetrical, so my little bracket can go in one way or the other, and I had it pointing at the top of the housing of that little magnet thing. Okay, now we should get the real, let's see, 158, yeah, 22. Is that the one we just got? 19, yeah. Okay. So that's good. It's working. Let me close this here so no dust falls in and there's no shenanigans. So this is now telling me that when I get to what the machine considers to be 0, it's actually, I've got my percentages calculated wrong, so I want to tell it that 19 is 0%, if that makes sense. So I don't have as much depth to work with as I thought. Now, last demo, since that's thankfully, I think I figured out what was going wrong there. I'm just going to fill it, and then we'll see. We should see that number go back up. I just heard the pump kick on. So that's the refill pump. And that's because that magnet, that ball, or that little float raised, which allowed the machine to say, okay, we can draw in water from the reservoir into the steam boiler and or the water boiler for the coffee. I can peek. I still can't see how far down that is. It's a really inconvenient design, to be honest. A little sight glass or something could have gone a long way. Now, depending on, I'm not looking at my I/O feed, depending, it may have already sent an answer that was like 10 centimeters or something. I've just filled it up almost to the top. I can hear the steam boiler heating up. It builds up pressure, and there's a valve that stops. Just went, and that means it knows it has enough pressure that it can stop heating it. I forget the name of that kind of valve. All right, so let's see. Did we change yet? Okay, so it hasn't updated yet. In about a minute, right? Yeah, a minute and a half. Glue a mirror to the bottom of the lid is a good idea, John Notch. A little 45-degree angle, or one of those fisheye ones, a little backup one. That would be a good idea. Somebody said I'm only 80% caffeinated. Have another. Oh my gosh, if that thing measured that, what would we find? Yeah, top of a car visor, John. Good idea. That's the solution I need for that. That's probably the solution to this whole thing, right? Is just make it easy to look. A periscope. I like it. Just need a camera. I just need a webcam pointed in there. I don't need all this IoT stuff. I guess that is IoT. All right. Tyeth says, you could have a fill mode. When you press the button after sending the data, it also flashes board's NeoPixel color to tell you the filling level for the next 30 seconds. I like that. I actually have it sort of doing a 2-second NeoPixel. You can't see it over there. Because originally when I first started testing this, I wasn't doing any of the AIO stuff. It was just a color for different heights. Code needs a fill mode switch that beeps a piezo speaker when full. Feature creep. It might have been, I forget, it might have been John last week who was talking about, John Nodge, talking about just adding a solenoid fill pump to. Since I'm using those big distilled water, I could put them upside down in a glug-glug gravity-fed valve contraption. Dave Odessa asks, what's the ideal temperature of the water to make the coffee? That's a great question. I have a little PID. It's built into the machine. There's a PID that flashes my water temperature for the coffee side of the operation, pulling the shot, and then the temperature of the boiler for the steaming. I have it set to 200 for the coffee, for the brewing side of it, and 260 for the pressure, the milk frothing pressure side. That does not mean that that's the temperature that gets to the coffee because it's going through the group head. And I believe, I don't know if there's a stock answer to this that people accept anymore because there's so many variables, but I think it could be like 197. I'm talking centigrade there, Celsius? Those are Celsius, right? That can't be right. It must be Fahrenheit. Yeah, I must have this on Fahrenheit. Yeah, that's my not very coherent answer to that. I would Google that and see what people are saying these days. But with the PID adjustment, like I used to, on my old machine, do what was called water surfing. So it would be overheated just sitting there. I would let water out and you would hear it really hissing and frothing as it was like kind of super boil. Wait till it calms down, then you'd go, and whatever that temperature was a good temperature. This one controls it much better. It's got a separate boiler for the water from the steam. The old one I had was a heat exchanger with a single boiler, so the steam coming off the top, water temperature down here, both of them were kind of a compromise. So you can see here, if you look at my AIO dashboard, we're now at 93% full. Again, I'll adjust these numbers. It's saying it's 2 centimeters roughly from the sensor. I might call that 100% and adjust the bottom end of it too. But yay, that means it's working. Sorry for the confusion when I had it flipped around. I don't think that was a problem until the water got below there, and then it would stop like basically 13 centimeters away from the sensor is where that little plastic nub was, and I was just always pinging that number. So, yeah, John, you're right. If I'm already over-engineering a way to see the water level, might as well throw in some auto refill. I love it. Okay, let me, just for fun, let's, I'll pull up the Discord over here. I'm just in my browser because it's bugging me. Check what the, okay, yeah. 197 to 205 is what a quick search is saying in Fahrenheit, or 92 to 96 Celsius is considered a good range to begin with. You know, a lot of these things aren't, you don't have to take them as written in stone. You can play around with them and adjust them. Same with the times and the amounts, like the 20 grams in, 30 grams out is a good starting point, but you can, it's not like a 45-second one is going to be terrible, or pulling 40 grams is going to be watery. Like, there's a big range for experimentation and play there, which is fun. Okay, I guess I could just keep going because now I'm full of this delicious cappuccino, but I should probably start to taper this thing down and end it, right? So that said, oh, by the way, just to follow up on the temperature thing, I also just recently turned down the temperature on my steam boiler because it was steaming so fast. Like, it's a very powerful boiler, and you don't want your milk to only get like a second of getting air in before integrating it, just because it's hard to do. So I've actually started to see if I can get maybe a little less pressure coming from that and adjust how I do the milk to get that nice sort of thick paint-like velvety texture. Andy said, JP's now buzzing. It's true. It's gone. I finished it. Should I make another? Probably not. Okay. Thanks everyone so much for coffee talk here today. This has been a fun project. I'm going to finish up some little case stuff for those. I'm so glad you were able to join me on the journey of figuring out the mystery of bad readings, because I was pointing it at the wrong part of the machine. But I think this thing works well, and Tyeth, I may follow up with you on some questions about how to do some of these possible wake-up things. And John Nodge, thank you for reminding me. Before I go, I want to remind you, Macchina, that is your coupon code for today. That will get you 10% off in the store. You know it's Italian because it's got 2 C's and an H, and you don't hear a ch. M-A-C-C-H-I-N-A, Macchina. That will get you 10% off in the store today. Head on over there. What are some of the things that I'm using in here, you may ask? It's a Feather ESP32S2. Not that one, not the one with a screen. We don't need a screen. We have the whole Internet of Things. We want that one. It's lower powered. I've got a Feather terminal block terminal block breakout Featherwing that it's plugged into. I am using the RCWL1601 as my sonar detector. That one works really well for this. And that's the main stuff. Also, this stuff is great. Silicon stranded core. I think it's the 26 gauge I'm using. Might be the one thinner than that, but if you have a couple of these around, they're terrific for doing this type of 4-conductor. We have, I think, a 6. Oh no, we have a 10, and often I'm stripping sections off the 10. In fact, if that's the only one we have the 10 in, yeah, this is what I was using, 28 gauge, because I peeled off a set of 4 to use that. Those are great. It gives you a neat bundle because it's the ribbon. It's real thin, fits kind of wherever. You can wrap it all around, and you can see I'm hiding it under the lid there. So those are some things you could get. All right. Are we going to end this thing? I think we're going to end this thing. Did I have anything else? No. All right. Hey, thank you so much for coming along to JP's Cafe here today. I am going to be back on Tuesday with a product pick of the week. I believe we have a deep dive with Scott on Friday, possibly a deep dive with Foamy Guy over the weekend, a Desk of Lady Ada somewhere in the mix. And then, like I said, Tuesday I'll be back with a product pick of the week. We'll do a 3D Hangouts on Wednesday morning. Check that out. And then a show and tell that evening and an Ask an Engineer. All good stuff coming up here. Okay. Thank you, everyone, so much for stopping by. That cracks me up, Seagrover. Said I need a speed adjustment to compensate for my caffeination on YouTube. Let me get out of here before I make a fool of myself. Hey, all right. Bye, everybody. See you next time. For your news, I'm John Park. This has been John Park's Workshop. Bye-bye.
I'm